Alright, so yeah, I'm just going to go over why NodeKit uses HyperSDK and why we believe it's the best tool for the job. So to go over that, I really got to give some background on kind of what we're building. So currently, blockchains are pretty fragmented, and rollups, at least on Ethereum, were built to kind of help essentially alleviate that fragmentation. But in the process, you really lost all the interoperability between them, leading to large liquidity fragmentation. So what we're building on NodeKit is a shared sequencer called Seek, which helps connect all these disjointed rollups, alleviating communication and allowing for much faster communication, making rollups easier to use and more accessible to new users. So to know what a shared sequencer is, you really have to know what the heck is a sequencer. So in traditional blockchains, you have this thing called a proposer, which is traditionally called a validator. And that's somebody who's building your blocks. And essentially, you have a leader-based system. For this example, I'll give a leader-based system. So you have a leader, and they're ordering these blocks. They're ordering these transactions for a singular block. And essentially, what a sequencer does for a rollup is that exact same thing, but essentially, it's centralized currently. And that causes issues with downtime. We've seen it before with Base, with Arbitrum, with Polygon. All of these systems, different systems have had downtime because of this core component called a sequencer. So a shared sequencer is a decentralized network of nodes, which allows you to share the sequencing between all these different rollups, essentially, which allows rollups to essentially unlock decentralization from day one. And essentially, it also posts this thing called a DA layer, which for a regular L2, that would be Ethereum. For an L2 that's using /u or Avail, that'd be Avail or /u. So the main benefits of shared sequencers are decentralization and interoperability. So essentially, what a shared sequencer aims to do is bring back the composability of a traditional blockchain to these layer 2 rollups. So it also aims to alleviate downtime currently caused by centralized components. So the reason why interoperability matters especially is essentially it allows you to have more synchronous composability using a shared sequencer, enhance liquidity, and global state. Separately, traditional solutions have allowed you to get one or the other. A blockchain like Solana or Avalanche C-chain would allow you to get synchronous composability among smart contracts and enhance liquidity as well as global state. But currently, that's limited to one blockchain. With what we're building at NodeKit, with shared sequencing, we're able to essentially enable this for many, many blockchains instead of just one, which enables greater unified liquidity and essentially a better user experience long term. So NodeKit is building Seek. We believe Seek will help unlock a better UX for rollups and help rollups grow to reach mass adoption. And essentially, we believe the current UX of blockchains is very difficult to use, especially for people trying to onboard to these rollups and trying to figure out how to use all these different chains. So we believe having a shared sequencer allows for better UX, will allow for a better user experience, and allow for these disjoint blockchains to become connected. So the way that we believe that this can actually happen is through this thing that we call an atomic composability layer. Essentially, this is allowing you to do synchronous, and by synchronous, what we mean is single block bridging. So essentially, what this unlocks is much faster bridging compared to all the existing solutions between two different disconnected blockchains. And we're able to do that because they are sharing a consensus layer under the hood, Snowman, which is essentially very fast and has a very fast finality, which enables us to be able to do interesting things around essentially having these things that we call block builders, which are specialized entities which allow us to have very fast bridging between two different rollups in one block, which enables a bunch of different use cases, which I'm going to go over later in the presentation. So to understand why this is interesting, you have to understand kind of what atomic composability is. If you've ever built anything with a database, you're probably familiar with the term ACID. Essentially, ACID, the first part of ACID in regards to database transactions is atomic. If something is atomic, that means either all the pieces of said transaction bundle go, and for database, that's state changes. And in this case, it's two transactions on two different rollups, or they either all succeed or they all fail. That's very important for users, because if it's not ACID, if it's not atomic, it essentially can lead to disjointed UX, where if you're bridging and one of the stops doesn't go, you end up with liquidity stuck on some random chain in a contract which might not even be yours. So it needs to be atomic for it to reach mass adoption, and that's why the current bridges of today are very difficult to use, and people have faced a lot of issues when they're trying to build these large cross-chain apps. So we believe that atomic composability, which is traditionally only able to be done on an L1 like Avalanche's C-chain, bringing that to layer 2s enables countless innovations, same as it did on the layer 1. With the layer 1, it enables stuff like flash loans, yield aggregators, decentralized stablecoins, restaking, essentially anything that uses 2 or more smart contracts is an example of atomic composability. It's essentially, the simple term for it is money Legos. Everybody who's built a DeFi application utilizes money Legos in some way, shape, or form, whether that's ERC20, ERC721. All these different standards allow for this composability and enables people to build these crazy things that we've grown to love in crypto. So essentially, we need to have atomic composability as atomic execution versus atomic inclusion. Traditionally, shared sequencers have only been able to guarantee, hey, these 2 transactions are going to be in a block for these different rollups, but they can't guarantee execution. To guarantee execution, you need this thing called a shared builder, which is essentially a shared entity that checks on both rollup 1 and rollup 2 that these transactions will succeed and is guaranteeing it. And essentially that allows you to have these super fast bridge transactions and allows for the end user to not even have to think about how it's done, and they can just submit a simple transaction. The builder will bundle with a secondary transaction, and your bridge transaction will happen within a single block extremely fast. So this enhances stuff like bridges, oracles, dexes. The days of liquidity fragmentation and having to bridge between 20 different chains could be gone. Essentially, oracles, as much as they might not love it, oracles can slash the amount of money they have to spend to support new chains heavily. So instead of a new chain having to spend $250K to $500K, which we've gotten those prices quoted to us from different oracles, and then bridges, large bridges having to charge millions and millions of dollars potentially to support different new chains, those prices can be slashed because once they deploy on one rollup that's inside the Seek network, all the other rollups can access these services, enabling much greater growth for new app chains, enabling them to get to market faster by focusing on more of the developer experience and the execution environment versus having to focus on, hey, I'm going to have to lobby this interesting service to deploy on my platform, and it gets really expensive for these services. And that's why we believe app chains have kind of struggled to take off massively so far, is when there's so much disjointed stuff and so much hard costs, makes it very difficult. But we believe that essentially shared sequencing and bringing atomic composability back will enable a much better developer experience and a much better experience for people that want to experiment with app chains or rollups in general. So how the heck did guys from Iowa and Wisconsin get here? Kind of going on a different note. So I went to Iowa State University. I dropped out back in October. Ricardo is one of my co-founders here. He went to Wisconsin-Madison. So now we are backed by A16Z Crypto Startup Accelerator, and we're going into that in March. So kind of give background on how the heck this all happened, why we're building this. I kind of have to go back to kind of the beginning. So we were a group of college kids in the middle of nowhere. I was in Ames, Iowa, because we saw decentralization and rollups being a pretty big issue because all of them were currently centralized, and it was a terrible bridging experience between them. So that was kind of our humble beginnings. But the problem was to build a shared sequencer. First of all, I'd never written Go, which is the language of most blockchains. So we needed a system that was easy to write in, but extremely high performance. So we needed fast time to finality and an extremely high TPS because it's not just one blockchain we're supporting, it's many. So after some consideration, looking at different stacks, we looked at essentially every single app chain stack. We looked at HyperSDK, and by a chance encounter in a BAF group chat, which is like a student group chat for college students interested in blockchain, we found HyperSDK through Usman and essentially Ava Labs, and we were able to develop on it, and we were one of the first builders on it. And funniest story is when we first started developing on it, they told me, they're like, if we hit 65K TPS, we're gonna be really excited if we hit that in a year. I believe they hit that in 2 months from the time we started. They were at 30K TPS, and there was a single README file, and the acceleration of HyperSDK has been insane to see from day one. And that's why we've been developing on it from day one. Even when the docs were sparse, we still were developing on it because it was simple to develop on. It was a stripped down app chain when a lot of these other app chain frameworks became bloated. And when you want to develop really crazy stuff, you don't want a framework that makes many decisions for you. You want the least opinionated framework possible because you just want to be able to focus on speed and getting the developer experience that you want at the end of the day. So after a couple weeks of finding out about HyperSDK, getting really excited, we built this.
Hello everybody, my name is Noah. I'm here today to show you how the NodeKit shared sequencer works with our get integration. So, as you can see on the screen right here, This is the chain watch feature for the HyperVM. And this is the live logs for the depth integration. So I'm just going to send a transaction just to show you how this works. Transfer between accounts. Choosing test 4. 1 Ethereum. Next. Confirm the transaction. So you can see it depending right here. You can see it shows up for HyperVM right there. It's finalized right here. As you can see the transaction in this block right here. So I just refresh my screen right here, and it's sent. And it's just that simple. Thank you for listening today, and we hope to have a bigger integration out soon. Thanks.
So as you can see there, it's extremely simple to develop on HyperSDK. We were able to develop extremely quickly compared to any of the other stacks. If we'd been using Cosmos SDK or Parachains or any of these other stacks, they would have been opinionated, and we tried them out, and they didn't work for our use case. Developing on a stripped-down stack may seem more difficult at first, but it's actually easier because as a software developer, I want to be able to make the decisions on how I do my development. I don't want to have to fit into some box of, oh, you need to use this thing, and oh, you need to use this thing. And with HyperSDK, we were able to make those decisions and build quickly and iterate fast, especially as a small team.
Hello, everybody.
Oh, there we go. Oh, is it advancing? It advanced on my screen. Let me see. Let's stop sharing and try again. Give me 1 second. Sorry for the technical difficulties. Okay, so since then, and this was all the way back in the summer, so I believe roughly June. So since then, we've built out Warp Block, which is essentially a primitive for us to be able to prove a light client of HyperSDK blocks on Ethereum. So ZK AWM is coming soon. That is a zero-knowledge proof version of Avalanche Warp Messaging, which we're very excited about. We have built out a bunch of improvements to the JSON RPC interface. We built out an S3 archiver, Postgres database, streaming from point in history, block hash, namespace Merkle trees. We hired 2 other developers who were working on HyperSDK initially on different projects to join NodeKit as well. For non-HyperSDK work, we've done some integrations for rollups such as OPSEC and Sovereign SDK. Oh, and we raised 1.2 million as well. But yeah, so build on HyperSDK, and yeah, I want you to build on HyperSDK. Thanks. Yeah.
So first of all, this is awesome work, so that goes without saying. So am I to understand, or do I have the right mental model that you allow a partial order to be established between 2 separate rollups?
Yep.
And so that's really fascinating, right? Is there a higher, so if I have A and B rollups,
Mm-hmm.
and there is a partial order between them, and then B and C also, is there a way to sort of relate the events? Because there's some overlap, like you could actually start imposing.
Yeah, so that's where it gets really interesting, and we've been thinking about it a lot lately because essentially most messaging standards currently are only built to have essentially a transaction initiates on one chain and then it triggers an event on another. And we're looking into different messaging standards to essentially allow you to bounce messages back and forth, but you could even bounce it between. And what I mean by bouncing is, so it's the same way as like how essentially like deliveries work. So like the UPS driver doesn't only have to drive between my house and Emmen's house. He could also stop at Ricardo's as well. So essentially that's things we're experimenting on currently is how to have stops in between to kind of have this multi-hop journey and making them trigger on events, which allows for really interesting stuff, especially on liquidity and allowing for price impact things because you can, and with this design, with our atomic composability layer, we've been talking a lot about people about how to essentially minimize price impact for different exchanges because when you're able to essentially, and this is getting into the weeds of it, but essentially when you're able to have these graph traversal algorithms and you're not limited to one chain and you're able to know that it's going to be atomic, you're able to essentially gather liquidity from many sources instead of one. So the multi-hop stuff gets really interesting, but you definitely have to just define some new standards on it because all the current bridges can't do it, which is kind of a cool thing.
That's what it needs to make.
Yeah.
Did you talk to the Oracle providers and how receptive were they? I can't imagine they'd be so, I can't imagine that they would be too receptive to this idea because they like selling their services to different chains, right?
Yeah, I don't think the Oracle providers themselves will be the most happy, but it's essentially, it's the same issue as like banks not initially being happy when everybody could have stuff like Swift in between them. Once you can have much faster communication, guaranteed communication, it enables you to do a lot more things a lot quicker. So I think it's one of those things where it's, like many things with computing, it's adapt or die. So the ones that move forward and want to adapt with the times and move forward with the times, I think they'll be able to scale and they'll be able to figure out other ways of monetization and other ways of essentially scaling their services up. But I do think that the big thing that this enables is roll-ups and app chains to effectively cut their costs a lot. And if we break a few eggs along the way, so be it.
Exactly, that's the attitude. Can I just say one thing? Like, it's so clear to me that somebody should do the following thing, which is take your system, create a subnet where there is Oracle data coming in at an immensely fast speed. But it's a dedicated net, so it can absorb that speed. It's not going to have to pay high fees. And then use your technology so that other roll-ups can take information from that feed at the pace that they desire.
Yeah.
And without having to pay any extra. You just have to pay once.
Yeah, we're looking into that.
Such a good use case.
We're looking into that because essentially the way that would have to be done is you need to do a ZK, you need to do not ZK, but you need to do an Avalanche warp messaging transaction from subnet 1, and then you need to essentially have some kind of communication in between to be able to receive it and then push it out to the other side. So we're looking into a lot of different stuff on that site. It's really interesting and also really hairy, especially when you have all these different messaging standards, but a lot of super cool stuff happening with warp messaging in general. We've been bullish before it even had docs. I think we started using it before Teleporter came out, so definitely we're early on that one.
Yeah, nice. This is my first time hearing about ZK AWM, so interested to see that implementation when you guys release that.
Yeah.
Are you open, is everything open source? Is all of NodeKit open source?
Not everything. So essentially our main subnet will most likely be open source, but most of the atomic composability stuff will probably end up being closed source for a little while, essentially just to make sure we can get it to market. ZK AWM potentially could be open source at some point. Obviously, it's about making sure that other people can innovate on top, but it's also about making sure you're keeping it nice and collected so you can make sure that you can sell it to customers as well. So balancing it out.
Yeah, keep it cool. Okay. Does anybody else have any other questions? Anybody? Not even Usman?
Oh.
Can you talk about the work you're doing with Supernova? I've seen in a couple chats.
Yeah, that's ZK AWM. So essentially, we're developing a light client for AWM that will be able to live on any chain. So one of the first primitives that we built out for Avalanche warp messaging, let me see if I can go back to the slide, is warp block. So essentially what that enables you to do is it enables you to prove that the block occurred on any HyperSDK chain. It wouldn't necessarily have to be ours, but it would be any HyperSDK chain, and you'll be able to generate a proof of that. And we've also developed a way to prove essentially the validator set for Seek as well. So once that stuff gets all finalized, we'll most likely release something later this year on that. But essentially, we've developed essentially the first ZK AWM light client, and we believe AWM in general can be used for a lot of different things. So this could also be used as a bridge or anything else. We're just using it as a light client because that's the use case we needed it for. But once you have ZK AWM, you're able to build a bunch of stuff on top of it. But for us at NodeKit, it wasn't. It's a means to an end. It's not the full product that we're selling. So, yeah.
Anyone else? Oh yeah, Usman's got one now.
Yeah, after getting called out, I actually thought of one. So being one of the first people who's actually built the HyperSDK, you actually understand it on a very deep level as opposed to many other devs. So seeing that, what other things do you think can be built with it, and what would you like to see be built with it?
That's a great question. So I would say what else could be built with it? I think there could be a lot of things built with it. I think a lot of the things that would be traditionally kind of difficult to build become a lot easier once you know that your base layer is working well, not going to have a lot of dependency issues. And I feel like HyperSDK is easier to develop on than a lot of other systems that we looked at. We did look at Cosmos SDK as well, and we found it difficult to develop on. so that was really the reason why we ended up going with HyperSDK was the performance and the ease of developer use. So I would say there's a lot of open things. You could, if you want to go and do stuff that NodeKit could build, obviously build oracles as subnets, or build, I've seen some data marketplaces that are coming out that's very interesting. Seeing some DA layers that could be interesting to build as a subnet. I think there's a lot of different things. I think overall, I would like to see kind of tooling being built out as well. I feel like that's the next big step, as well as somebody needs to put like the SVM or some other novel VM or some privacy thing, or potentially an ABCI compatible VM kind of interface on top of HyperSDK. There's a ton of stuff you could build, but it's hard to pick just one.
What kind of tooling would make sense to help you out?
So we're currently working on some of the tooling stuff ourselves with Ash. So right now we're adding Docker support. So we're doing that right now. So that's one of the big things for us, because a lot of our stuff needs to be automated for customers. So that was kind of the first thing that we're building out. I would say a lot of the tooling is getting much more mature. It seems like it's kind of exploded overnight. Since November, it's been like night and day difference on a lot of the tooling stuff being able to get done. So yeah, I would say tooling in general is hard to pick just one thing, but anything to make it easier for developers to build on top of it is always appreciated. So really just stuff around DevOps, I feel is it's not the sexiest stuff ever, but it's really always needed, because to scale up and be able to scale to all these different customers, you need to make sure that it's easy to deploy for the customers as well. So yeah, might not be the greatest answer, but I would say DevOps is always crucial.
Cool. Anybody else?
How easy it is for existing L2s to integrate with the sequencer?
Yep, so essentially we've built out integrations for OpStack, OpenSDK, and a few more on the way as well. So the way it works is an existing L2 typically requires a bit of smart contract work, but most of the work is actually on essentially a forked version of their stacks. So it depends obviously on the L2s. Most of the times we do the L2 integration work, and then we're able to essentially just transfer it over to them. So essentially they're able to, it's not really a fork or anything like that for their chain, it's just them changing a Boolean value to say, are we using centralized sequencer or none? So it should be quite easy long term for them to use it.
Any last questions? All right, well, thanks, Noah.
Thanks for having me.